Hello, everyone. Whoa, there are a lot of people here. I thought I was nervous this morning when I was thinking about the talk, but now that I'm here, now I'm really nervous. First of all, I would like to thank the organizers of the event for inviting me here. It's always a pleasure to come back to Barcelona to enjoy the Rodalies and the traffic jams in the city. Thank you very much for that. I appreciate it. So my talk is about Kubernetes. The title is Kubernetes is a platform, not just a deployment tool. But let me warn you, this is the version 2 of the title. The first, the first title was this one, but I was having a hard time getting the talk accepted on conferences, so I decided to change it. It works. Okay, so what are we going to see today? First, let me introduce myself. I'm Jose. This is my Twitter handle, if you want to know more about me. I've worked in the past in different companies doing Kubernetes-related work. I work at Shifted, that now is called Adevinta, developing a platform as a service on top of Kubernetes for a couple of years. And now I'm part of CloudBees, the company that you might have heard before. Is the company behind Jenkins, this tool that no one likes but everyone uses. And I'm developing some features on top of Kubernetes as well. So I don't have all the answers about Kubernetes, but I have some experience that I'd like to share with you today. So what are we going to do today? Closer. Okay, the agenda for today is this. First, we are going to see how Kubernetes works internally. Then we are going to take a look at the Kubernetes API and what makes it special. Then let's discuss how we can extend the Kubernetes functionality. And at the end, we're going to talk about Kubernetes as a platform and what do I mean by that. Okay, so let's start with the beginning. But before jumping into the topic, don't worry. Oh, sorry. Don't worry. If this is not your typical Kubernetes one-on-one talk. I'm not going to explain all the different objects that you can find on the Kubernetes API, like there is an object called a pod, there is an object called a deployment, and it does this and that. I'm not going to do that. But don't worry if you haven't used Kubernetes at all. If you need to know a little bit about an object in Kubernetes, I'm going to explain it briefly, so don't worry, and you will be able to understand everything that we talk about. So let's do a small group exercise, okay? Let's try to program a thermostat. I want you to picture yourselves some years ago when you were trying to learn object-oriented programming. I want you to close your eyes and picture yourself in the university or in the summer camp or whatever you learn object-oriented programming. If some of you start screaming, it's because maybe you don't like object-oriented programming. And imagine that you are there and your teacher asks you, how would you program a thermostat using an object-oriented programming, right? How would you do it? Don't worry, I'll help you. We could say that a thermostat is something like this, like the device that we hang on the wall to select the current temperature for the room. And how would we go about programming this kind of device? So if we use pseudo object-oriented language, this is not valid Java, but let's say for the sake of argument that it compiles. How would we go about this? This is a loop, an infinite loop that will go forever. It's a while true loop. And it's doing some things inside of the loop. The first thing is it gets the current temperature on the room, right? We need some kind of sensor or complex device that allows us to get the current temperature in the room, something really complex and expensive like a thermometer, right? That way we can know the exact temperature in the room. The next thing that we need to do is to get the desired temperature. The user will use the thermostat to select what's the desired temperature that they like on the room. So we use just the user interface on the device itself. And then, now that we have both the current temperature and the desired temperature, we can enter if I go, okay. We can enter into the loop, and we will try to reconcile both states, the current state of the temperature and the desired temperature. If the current temperature is lower than the desired temperature, we will heat the room. If the current temperature is higher, then we will cool the room, right? This is easy. This is a naive implementation on a thermostat. But I can see some faces wondering where are we going with this, really? But that's the problem with a single track conference, that you're stuck with me now, right? So you will have to complain to the organizers, but trust me, I'm going somewhere with this. If we understand how a thermostat works, we can understand how Kubernetes works, because that's how Kubernetes works. And throughout the talk, I'm going to show you what I mean by that. Okay, now, let's talk about the Kubernetes architecture. If I can go back. Okay, here. Kubernetes is not a monolith. It's a set of processes that they all work together to achieve what they want to do. And these processes are being run inside of the cluster, inside of the servers. And I think I'm going to stick here. Okay, some of these processes are special, and these processes are called controllers. These controllers react to changes on the API. They are watching the Kubernetes API, and whenever we change anything on the API, they react and they do something about it. So this is called the reconciliation loop. The same way that we talk about the thermostat always trying to reconcile the current temperature and the desired temperature, these processes, the controllers, they try to reconcile the state of the cluster. So each of these processes, each controller, watches the current state of the cluster, and they compare that to the desired state of the cluster. They are always executing inside this loop, this reconciliation loop, and if the desired state and the current state don't match, they execute the required actions to make the current state match the desired state, right? Much like the thermostat. So we said that we could program a thermostat more or less like this. How would a controller would look like if we do the same exercise with a controller? It will be really, really similar. We will have the same infinite loop that will go on forever. And first, we will get the current state of the cluster, and then we will get the desired state of the cluster. In the thermostat example, we were using thermometers and stuff like that to get the state. Here, Kubernetes is using a database to store all of that state. In this particular case, we are using etcd as a database, but you don't really need to worry about that. And once that we have the states, the desired one and the current one, we just try to reconcile that forever. Two questions may have popped up in your head now. What do we mean by a state when we are talking about Kubernetes? With the thermostat, it was easy, it was the temperature, but what do we mean now? And how do we choose what's the desired state now? What do we mean by a state? It could be lots of different things. Instead of being the temperature, like in the thermostat, here it could mean what applications must be running on the cluster on a specific time, or how the traffic must be routed to the applications inside the cluster, or if you have some periodic jobs that you want to execute, like cron jobs, that is also a state that we can save on the cluster. There are lots of examples about this. And how do we choose the desired state? On the thermostat, it was easy. We were using the user interface for that device, and we just select the number of degrees that we want in the room. How do we do it in Kubernetes? And that's how we are going to talk about the Kubernetes API, the next topic in our agenda. To save the state that we want, we are going to use the API. We use the API to save the desired state on the cluster. And Kubernetes has a RESTful API. This API, you may think that it's something really complex because it's Kubernetes, so it must be something really special and over-engineered, but it's just a RESTful API. the same RESTful API that you could be using inside your company for your products, or the same RESTful API that you use to integrate with third parties like Twitter, Facebook, or Stripe. So it's just a RESTful API. Actually, the image right here is the Swagger or Open API documentation for the Kubernetes API, the same that you would use in your day-to-day RESTful APIs. And this RESTful API exposes a model. And when I talk about a model, I talk about a set of objects that are present in the API. These objects are what you usually hear about, like the deployment object and the path object and so on. And this model describes how applications must behave when they are running inside the cluster. And using these objects, these resources that are defined on the model, we can describe the desired state. This model doesn't have any operations on the objects. We create the objects to state what's the desired state on the cluster. And we save these resources, these objects, using the Kubernetes API, like in any other RESTful API. OK, let's see an example now. Here, in your right, we are seeing an object in the Kubernetes API. This object is called the replica set. Don't worry if you haven't heard about it. The replica set object defines how an application is deployed on the cluster. So it's just a JSON object, like if you want to create a tweet using the Twitter API, you will send a tweet described as a JSON object to the Twitter API. So it works the same way. And this object lets you define important things like which Docker image to use inside your application. In this case, we are using the Nginx Docker image. It lets you define which ports you want to expose on that container. And it lets you define things like how many replicas, how many instances of your application you want to be you want running concurrently. So if I want to save this object on the API, normally we will get an HTTP client. We will try to send like an HTTP request, a post request, or a pull request to the API in order to save the object, right? We will send the same replica set.json object that we just saw in the previous slide. But this is an oversimplification on how it will be done, because you have to take care of authorization, you have to know which endpoint to hit, you need to know the format, and so on. So happily for us, Kubernetes also gives us this command line tool, which is called kubectl or kubectl, or depending on who you ask. And you can use kubectl. I'm in the kubectl team. If you use kubectl, you can create the object just with this command. You don't need to know all the tiny details about authorization and how everything works. So we can create the replica set object in the Kubernetes API using this command. And one of the important things here, one of the key things, is that remember the processes that I told you about before, the controllers that were watching the API? There is one specific controller, one specific process that's called the replication controller. And this replication controller is watching the API and reacting to changes whenever we create, update, or delete a replica set object like we just did. So I have a video that showcases how this all works. Let's hope the demo gods are with us today. OK. Here in the left, you can see the same replica set object that we just saw earlier. It's the same. And on the right, let me pause the video for a second. In the top right corner, you can see the list of replica set objects currently created on the cluster, which is none. There are no replica sets created. On the bottom right, you can see the number of replicas, the list of replicas of my application, which currently is none as well. Okay, so we don't have any instances of my application. Let's continue with the video. So I'm going to create this replica set object using kubectl, like I told you. And once I create this object, the replication controller will react to that change on the API. And suddenly, let me pause the video again, I have 3 instances of my application running on the cluster. I didn't start those instances. The replication controller started them for me. And we can see the replica set object created in the top window. So it automatically have reacted to that change and created the required changes to match the desired state, my applications with 3 replicas, with the current state, which was no replicas whatsoever. Similarly, if I go to the replica set object and I change the number of replicas from 3 to 10, let's say, then the replication controller will get notified of this change on the API and create the 7 missing instances of my application. I don't have to do anything manually. I don't have to talk to the API to create my application. The replication controller automatically picks up those changes and does everything that it needs. So you can watch resources in the API to react when the desired state and the current state don't match, and decide which actions you want to do to reconcile both states. In the case of the replication controller, is starting new instances of my application to make both states match. Okay, this is pretty much the same as the thermostat that we saw on the beginning. And I told earlier that the Kubernetes API is just a RESTful API. It's nothing special. So you may be wondering, how do I watch for changes on the API? If it's a RESTful API, how do I do it? And the answer to that is programmed on the Kubernetes API itself. And if I want to watch for replica sets object, which is the endpoint that we have there, the only thing that we need to do is to add this parameter to the URL. If we use an HTTP client, like curl in this case, and we send this HTTP request, our HTTP client will keep the connection open, and we will start receiving events. So we will start receiving events every time there is a change on the API, like we just saw earlier. So imagine that I create the replica set object. Then my HTTP client will start receiving those events, those JSON objects. In the very top, you can see that the type of the event is added because we just created a replica set object. We just added one. And we also get the full description of the replica set object itself, and we can do whatever we want with it. For instance, take a look at the number of replicas and create those number of instances of the application. So when creating a new resource, we get its entire definition. Same way when we modify the replica set. When we modify the object, we get the new object definition, and we can use that to compare it to the previously state and take the actions that we need to take, like if the number of replicas is lower than the number of replicas in the previous replica set object, maybe we have to kill some of the instances of my application. And finally, if we delete the replica set object, we also get an event saying that we have deleted the object. That way, we can use the event for garbage collecting some objects in the API. So when we create a Kubernetes cluster, some of these processes, some of these controllers are installed in the cluster by default. So there are some default controllers that are already running and watching for changes on the API. For instance, the replication controller, the one that we just saw. But there are plenty of more, like the endpoints controller that takes care of the service object, or the node controller that is watching if nodes on the cluster go down, or the service account controller that takes care of token the authentication and tokens for the users in different namespaces. But there are plenty of those. Okay, so here's the kicker, though. Here's the surprise. Not all the resources are being watched by a controller. So the Kubernetes API has a huge list of different objects that you can create, that you can use, but not all of them are being watched by a controller the same way that we saw earlier with the replica set. Let me introduce you the Ingress object. The Ingress object defines how the external traffic is mapped to services inside the cluster. And you can use this object, which is here on the right in JSON, You can use this object to describe how you want the routing in your cluster. For instance, you can route HTTP requests based on the host header. For instance, here we are only answering requests going to foo.bar.com. And you can also do routing based on the path. So in this example, if the path is /foo, it will go to service 1. If the path is /bar, it will go to service 2. Okay. I told you that not all the resources in the API are being watched, and the Ingress is one of them. No one is watching the Ingress resource. If I create this object that we just saw, nothing will happen because no one is watching this resource and making sure that whatever I define on the object is taken care of. No one is watching that object. So why is there, right? You need to install what we call an Ingress controller. You need to install a process that watches the API for Ingress control, for Ingress objects. You could install this one, for instance, is the Nginx Ingress controller. This controller watches the API for Ingress objects, and whenever we create, update, or delete the Ingress object, it will make sure that those rules apply. So when you install the Nginx Ingress controller, you get basically two pieces. On one hand, you get the Nginx proxy. I guess most of you have heard of use Nginx in the past. You get the proxy itself, but you also get a process that's watching the API and that it will render the Nginx configuration file, and it will be transforming the Ingress rules into the Nginx configuration file. That way, the Nginx proxy is always using a configuration file that matches with the rules that we define on the Ingress object. So that Nginx Ingress will make sure that those rules, that configuration, apply in our cluster. So we need to install it. But you don't have to install this one if you don't like it. You can go with a different implementation of an Ingress controller. You can use the HA proxy or the comp or traffic. There are plenty of different implementations of Ingress controllers. The first one, the Nginx Ingress controller, was made by the Kubernetes team. But the rest of them, they were made by other teams, other companies that were interested on integrating their products with Kubernetes. And this is really important here, because this brings us to our third topic, how we can extend the Kubernetes functionality. I told you that only the Nginx Ingress controller was created by the Kubernetes people, right? The rest of the Ingress controllers were created by other people. That means that we can create our own controllers, basically. You can create your own controller. Since the controllers are using the API and the API is using HTTP, we just need an HTTP client. And we have HTTP clients in Go, Python, PHP, Java, every language out there. So we can create our own controllers in the language that we like. And since we can create our own controllers, we can do anything we want, really. We just need a controller that watches the API and do something based on that change. But that something can be anything, really. So, this is interesting. Remember the Ingress object? We said earlier that we were only replying to requests coming to the host header foo.bar.com, right? That means that somewhere someone has configured a DNS provider saying that the name foo.bar.com must go to this cluster in my local network. So someone somewhere has configured a DNS provider for that in order to work. And I told you, yeah, the DNS there. And I told you that controllers can do anything we want. So, why don't we create a process that is watching for Ingress resources? And whenever we create an Ingress resource, it takes the host key from the Ingress definition and automatically creates that name in my DNS provider. If I do that, I don't have to do it manually. I don't have to do it with two different processes. A controller can do that automatically for me. So that's basically what this controller is about. This is an open source controller that you can install on your Kubernetes cluster, and is a controller that's watching the Ingress objects in the Kubernetes API. And it creates DNS entries in your Cloud DNS service automatically. So you can configure Google Cloud or Route 53, whatever provider you want, and it will create automatically those DNS entries for you. So we are solving an infrastructure problem using Kubernetes. We don't have to have two different processes to solve this issue. And there are lots of open source controllers out there. This is just an example. For instance, the Prometheus Discovery is another controller that you can install on your server. If you are using Prometheus to monitor your services, you have to take care of the Prometheus configuration file that contains the list of services that you want to monitor. This is a task that we need to do. And installing this controller, we can make the controller automatically update the configuration file for Prometheus whenever it detects that a new application has been created on the cluster. So we don't have to do it manually anymore. Also, another controller, Reloader. Kubernetes has two different objects that we can use to store configuration values. Those objects are called config maps and the secrets. And normally, we use those objects so that applications can read the values from those objects, but they normally only read those values during the bootstrapping of the application on startup. So if I change a value in a config map, my application won't notice. So you need to restart your application. This controller, Reloader, will automatically detect and react to changes in config maps and automatically restart your application whenever a new change has been detected. So you don't have to do it manually. So what do I mean by Kubernetes as a platform? We have seen a couple of controllers examples that you can find out there. What do I mean by that? The built-in resources that are exposed in the Kubernetes API model, they may not be enough to describe all your different use cases. And the cool thing here is that the team behind Kubernetes has acknowledged that. They know that the model may not be enough. So they have put in place a system that makes you create your own types on the Kubernetes API. You don't have to be limited to the set of objects that are available on the API. You can create your very own. Those are called custom resources. And you can create a controller that watches these custom resources. So the coolest thing here is that you are not limited to the native objects in Kubernetes for controllers. You can create a controller with your own logic that reacts to changes in objects that you have created, that they don't exist on Kubernetes by default. When you combine your own controller and your own data types, is what we call in Kubernetes the operator pattern. And there are lots of examples out there. For instance, the cert manager is an operator that retrieves TLS certificates for your applications automatically. So they wanted a way to automate how we retrieve the TLS certificates. And they introduced a new object in the Kubernetes API. This object is right there. It's called the certificate. And this object is not there in Kubernetes by default. You have to install it when you install this operator. And this new object, the certificate object, is just a JSON object. And here we can configure things like which domain I want the certificate for, and which provider to use to get the certificate. Like I want the certificate from Let's Encrypt, or I'm using my own Vault instance, I want the certificate from there, and so on. So creating on the API this object, this certificate object, the operator, the process that's watching the API for changes on objects from this type, will react to that change and automatically fetch the certificate from me. I don't have to do it manually. I don't have to have another set of process, another set of tooling to create those certificates. I can use the same tooling that I use to deploy my application. The important thing here is that those custom resource definitions, those objects that we create, they let them describe what we want, not how we want it. We just declare what we want. How it's done, we don't know about it. The what is described in the resource. I want a certificate, a TLS certificate. I want a certificate for that specific domain. And the how is programmed inside the operator, inside the controller. How the certificate gets created, I don't know, I don't care. I only care about defining how, what I want. So we are decoupling the how from the what. Another example, this is the Amazon Service Operator, and it lets you manage and create Amazon resources from the Kubernetes API. So this operator doesn't create one custom object in the API, but it creates lots of them. Here we have an example of the S3 bucket. So there is a new type on the Kubernetes API, and this type is called S3 bucket. And if I need an S3 bucket, I create this object in the Kubernetes API. I describe what I want, which is the S3 bucket, some configuration like if it's public or private or whatnot. And the controller will react to that change and create the bucket for me. How it was created, I don't care. How do I need to use the Amazon API to create the bucket? I don't care. Who has the credentials to talk to Amazon? I don't care, I don't know. The controller takes care of that, and I, as a user of this system, I don't have to know about that. So when I talk about Kubernetes as a platform, I'm putting my thought leadership hat now, so this may be fussy. But what I mean is that Kubernetes lets you handle all your infrastructure problems the same way. You don't have to configure different, what I call snowflakes. I've been on different companies before, and they were using different solutions for similar problems. If you use these patterns, the Kubernetes patterns and primitives become standard. So if you change from one company to the other, they all look alike. When something goes wrong in the creation of an Amazon resource, you know where to look because you know that it's a process that's watching the Kubernetes API, and you know that you have to go there. You don't have to learn because the process is running on some Jenkins instance over there, or you have a cron job configured on this instance over there. You configure all your processes on the same infrastructure. Another benefit of this is that we are using a declarative model over imperative model. I've suffered in the past where someone changed manually something, like for instance, a policy in an S3 bucket, and they changed it manually, and that change was not populated to the configuration file. So then the real state of things doesn't match anymore with the state that we have documented in source control. And those changes will add up over time. If we are using a declarative model, those controllers are running infinitely and making sure that the current state matches the desired state. So if someone wants to change something manually, they can do it. They have to go through source control, some review process, and all the good tooling that we have normally for code, because they can do it manually. If they do it manually, on the next iteration of the reconciliation loop, their change will be gone. So they can do it manually. So we have processes that are making sure that the desired state is what we really want. And if something goes wrong, they will fix it. So the system is automatically being healed by itself. This pattern is becoming really popular in Kubernetes, and more advanced operators are being created. Probably most of you have heard about Istio. Istio is what we call a service mesh, so it lets you define the configuration for traffic management inside the cluster. And Istio is just a really advanced operator, but it's just an operator. Last time I checked, I think it creates like 50 new types in the Kubernetes API, so it's a complex operator, but it's just an operator, a set of processes and a set of new objects that you can use in the Kubernetes API, and they will make sure that the networking configuration is in place. Another example, Knative. Knative is a project that comes from Google, and it has 3 different parts: the build part, the eventing part, and the serving part. And it lets you do things like deploy your application in a serverless mode, but running inside Kubernetes. So they create new objects in the Kubernetes API that you can use, because Kubernetes was not created with serverless in mind, but now we think it's a good idea. So someone is creating that use case inside Kubernetes API. We don't have to be limited with what they thought when they created Kubernetes. Another example is Jenkins X. Disclaimer, I work for the company behind this product. Jenkins X is just another operator. It lets you do CI and CD inside Kubernetes. It lets you have different environments like production, staging, QA, and whatnot. And for instance, those environments are just objects in the Kubernetes API. If you want to create a new environment, you just create an object in the API. That's it. There are that many operators nowadays that there is even this tool that you can use to find and search for operators that you may like, because it's a pattern that's getting really popular in Kubernetes. All of these operators, they provide a higher level abstraction on top of the Kubernetes resources, right? And maybe in some time, I don't know, I'm trying to see the future here. In some time, users will use this new layer of resources instead of the built-in resources. Like maybe in some time, using the deployment object, which is built in Kubernetes, or using the service object, which is built in Kubernetes, is seen as working with two-level objects. Because even though Kubernetes is stable nowadays, we are still learning what's the best way of using it and what's the best level of abstraction. So the user experience is getting better by adding these new types on top of the API. So we are constantly learning. For instance, most of the things that Istio has been added lately to Kubernetes, maybe they are putting back in the Ingress object in Kubernetes in the future, in the next version of the Ingress object. So we are still learning. But the cool thing is that we are not limited by Kubernetes. We can create our own user experience and create those higher level abstraction objects that we can use to solve our different use cases. So maybe in the future, we no longer use the Kubernetes objects, but we use the higher level abstraction. In the end, those will be used, but not by the user, but for the operators. As someone wiser than me said before, Kubernetes is a platform for building platforms. It's a better place to start, not the end game. Kubernetes is hard to maintain. It's not an easy task to do. So if you do it, if you select to go with Kubernetes, I advise you to get the full potential of Kubernetes and use it with all the capabilities that you can get for it. Thank you very much. Before the questions, I lost the presentation. Quería enseñar una más. Sí, pues que no se ve ahí ahora. Yeah, if you register for the conference, don't forget that you have this URL that you can go to get a discount on some courses in Spanish. So yeah, use it. Questions?